Hello there. Powerball was in the news recently, so I thought it'd be fun to look at the probabilities for winning and how much you win and the likelihood of those different payouts, and then trying to calculate the fair price / expected value of Powerball. It's a little bit tricky because the jackpot varies each time, so we have to decide on a number, and let's say that I'm only going to be interested in playing Powerball if there's a $100 million cash payout, or larger. So let's work with $100 million for our payout. I'm trying to calculate expected value, and the formula for that is the sum of each payout times the probability of that payout occurring. So it'd be $3 times the probability of getting that $3, plus $4 times the probability of getting that $4, plus $7 times the probability of getting that $7, all the way up. Expected value is the same idea as fair price, so let's put that in here. And I believe the cost of a Powerball ticket right now is $2. It used to be $1. Okay, this one is going to be totally huge, so I don't know how much space I'm going to have in this slide, but I am pairing these combinations, so I'm going to write down a couple of those. So that's the first one I have to multiply. I'm going to do the payouts, the prize money in green, and then the probabilities I'll do in black over here. Okay, so this gets added to, so that's the 3, then I have to move up to the prize of $4, then I move to the $7, and so on and so forth, all the way up to the grand prize. And we're saying the grand prize is $100 million, so I'm doing that $100 million times 1 over this monster of a number here. So this is a real hassle to enter into the calculator, but you'll notice that there wind up being, for this version of Powerball, I think it may have changed, but there wind up being 195,249,054 different combinations. So there's only one that's going to be the winning combination, but there are 3,162,510 different combinations, unique combinations that would get you a $3 prize. So that's where you don't match any, but you get the Powerball right. So, okay, so all of these denominators are the same, so I can actually factor that out in front, and then I'm not dividing by that whole thing. So I can do a little algebraic trick here where I'm factoring out that denominator. So that comes to the outside, and that makes the rest of this a little bit more manageable, because it's not going to have fractions on the inside anymore. So on the inside here, I'm going to have 3 times that 3 million number, and then I'm going to move over to the 4. So I'm putting them in parentheses to help denote what's going on. Then I move over to the $7 prize. Actually, there are 2 $7 prizes, so I'm keeping them separate. And again, so on and so forth until I get down to the end, which is that $100 million prize, and there's only one way of getting that. So this is more manageable because I don't have the decimals. Sure, it's a huge string of numbers. I could actually do this as list 1, entering $100 million here. This is list 2, and define list 3 as being the product of these two. List 2 being, well, you could do it either way, but list 2 being the numerators in this case. But I'm going to evaluate this huge number here. So a pretty big sum, and now I can multiply that by what I had factored out previously, and you'll notice that that is not as big as that, so this isn't even coming up to $1. So rounding up, I get 0.686878 so not even, just about 69 cents, the expected value, and I'm paying $2 for the privilege of getting a piece of paper that on average is worth 69 cents. Awesome. Guess I gotta wait for it to hit that 600 million. Character and scholarship for life.